Welcome back, students. Today we are going to see while loop. Using while loop, we are going to do few programs, finding the sum of digits of a given number, finding whether the given number is Armstrong number or not, finding whether the given number is palindrome or not. So these are the general programs. Before going to the program, let us learn how we are going to extract the digits of a given number. For example, let us take n is equal to 6, 7, 8, 9. So we have to extract each digit to get the total of all the digits, that is 9, 8, 7 and 6. When we divide a number by 10 and take the remainder, the last digit, that is ones, remains as the remainder. So the condition given here is when n is greater than 0. Now n is 6, 7, 8, 9. So it is true. Now we have a variable called LD, that is last digit, which is equal to n mod 10. So when it is dividing by 10 and getting the remainder, 9 remains as LD. The next step, we need to extract 8. So we have to remove this 9. So that is ones. That can be done dividing by 10. So when we divide and get the quotient, 6, 7, 8 remains. And this is the first round. And the second round again it is going to do from the beginning, because already it is n is 6, 7, 8, 9. Then mod 10 will become 8. The next time again we are going to divide by 10 and get it becomes 67. So n is 67, again mod it becomes 7. Then n is going to be 6 when we divide by 10. And the last round, last digit will be 6, and then when we divide this by 10, 0 is the quotient, then the condition doesn't satisfy, it will come out of the loop. So this is how we are going to extract each digit from a given number. Let us go to the program. New class, as special number I will do. Let us take parameterized input. So we will have name called input itself, integer number as n. Let us have d, that is int d, or capital D we will give, and then sum we have to initialize as 0 here. Then we will go to condition while n is greater than 0. We will have a block of codes. So now first time we are going to extract the last digit by saying d is equal to n mod 10. Then the last digit is going to be added with the sum to find the sum of that number. So sum is equal to sum plus d. So next we have to remove the last digit. For that we have n is equal to n divided by 10. So automatically ones get removed, and then the new n becomes after removing the last digit. So it will continue up to n is greater than 0. When it is false, it will come out of the loop, and then we will here print the sum of all the digits. System dot out dot println of sum of all the digits present in the given number is equal to plus sum. So let us compile this. No syntax error. Let us run this program. Let us give 15. So sum of all the digits present in this given number is 6. So 1 plus 5 is 6. Let us try with the bigger number. Sum of all the digits present in the given number is 31. I already told you while loop can be used when we doesn't know how many times we have to run the loop. So we doesn't know here in this program how many times it is going to be executed. If we give 2-digit number 2 times, 5-digit number means 5 times it should get executed. So we have given only the condition n is greater than 0. Number of times automatically it decides until n is going to be greater than 0. This is the benefit of while loop. Let us see how to find whether the given number is Armstrong number or not. Let us first know what is Armstrong number. When a number is equal to the sum of nth power of digits in that number, the number is called Armstrong number. For example, if we take a number 2, 3, 4, 5, then there are 4 digits available. So 2 to the power 4 plus 3 to the power 4 plus 4 to the power 4 plus 5 to the power 4. We calculate the sum of this. If the sum of this is equal to the given number, that is 2, 3, 4, 5, then it is called Armstrong number. Generally, we will have 3-digit Armstrong numbers. For example, 371. So there are 3 digits, that is 3 to the power 3 plus 7 to the power 3 plus 1 to the power 3. So this is 27, 7 to the power is 343 plus 1. So the sum of this becomes 371, which is again equal to the given number. So it is an Armstrong number. So let us do a program now. Here, instead of finding the sum of each digit, we are going to take cube of each digit. So that is d into d. So we need to give the condition to find whether the given number is equal to the sum of this number. But originally the number doesn't remain as we have given, because here it is manipulated again and again by dividing by 10. So let us put this into a variable called x. X is equal to n. So what we do, we preserve the copy of the given number in x. So we will not lose the number given by the user. Now we will have the condition here. If sum is equal to x, then we will say given number is Armstrong number. Else not a Armstrong number. So here we have to declare int x. Then everything is fine. Compile this. So let us give the Armstrong number, that is 371 itself, or even 370 also Armstrong number. Given number is Armstrong number. And then 153 also Armstrong number. Let us have 153. Yes, given number is Armstrong number. Let us give other than the Armstrong number. just for verification. 475. So given number is not a Armstrong number. Now let us do a program to find whether given number is palindrome or not. A palindrome number is a number when it is been reversed also gives the same number. So let us learn how it works before going to a program. It will be easy to do a program then. So let us have n is equal to 1, 2, 3, 4, and then when we reverse that, the new number should be there. For that we initialize r as 0. The condition while n is greater than 0, we have to take the remainder. So we are doing n mod 10, then we get 4 as the number. Here we will have r into 10 to make that remainder to the higher place value. Here r is 0, so 0 plus d, it becomes 4. The next round n is equal to n by 10. We are going to remove this 4 by dividing that by 10. We will have 1, 2, 3 now. The next round d is equal to 3 after getting the remainder. Now r is 4 already here. So what happens? 4 into 10. So the ones place moves to the next higher place, that is tens, by multiplying by 10. So it becomes 40 plus the remainder here, that is d is 3, 43 it becomes, and then again we are going to divide this 123 divided by 10, and then we will get 12 as the answer. The third round d becomes 2, and then 43 we already have into 10, so 43 becomes 430, and then this last digit is going to be added with this. It has become 432. Now n is equal to 1. Now the last digit is 1. We are going to multiply this r into 10, that is 432 into 10 plus 1. So it becomes 4321. Then when we divide that 1 by 10, it becomes 0, which is false. Then it comes out of the loop. So this is the working of reversing a number. So we will compare this with the original number given by the user. So if both are same, then it is said to be a palindrome number. So let us go to the program. So we will modify this program. Instead of sum, we will have r. Then while n is greater than 0, d is equal to n mod 10. Then we are not having this sum. Instead of that, we are going to have r is equal to r into 10 plus d. Then n is equal to n mod 10. So we have already stored the number in variable called x. So we are going to check whether r is equal to x or not. Then if it is true, then it is going to be palindrome number. It is palindrome. Else it is not a palindrome. Let us run this program. Let us give 1 4 1. Given number is palindrome. Let us give some other number. This is not a palindrome number, so it should say yes, it is not a palindrome number. Students, I hope you clearly understood how to use while loop and then do these programs.